Here we are in Chapter 2 Review Exercises, numbers 22 through 29. This is all in translation to math. These four problems, we just have to write out what it is translated into math. Here we actually have to solve an equation once we get there. Starting with number 22, the average. Now, how do we do average here? We've got 13p, negative 35, and z. That's data, our variables were already given. Our plan, average. That means we're going to add up and divide by the number there are. So we're going to take 13 plus p minus 35 plus z, all divided by 4, is equal to 128.6. Excellent. Number 23. There are 4 times as many cars as trucks. Oh, this is a tough one. There are 4 times as many cars as trucks, so cars have more of them. So let's think about it. The number of cars is 4 times the number of trucks. That's the best way to think about this. And this is a tricky one. There are 4 times as many cars as trucks. Cars is the most. So the number of cars, let's write this in a different one. Cars is 4 times the number of trucks. Now, lots of people will put 4 times cars equals trucks. That doesn't make sense. There are 4 times as many cars as trucks. That means there are more cars. Now look at this. If there were 2 trucks, 2 times 4 would be 8 cars. If there are 3 trucks, 3 times 4 is 12 cars. So you got to make sure that your formula makes sense with what is being said here. And for some reason, this wording, you think about it too much and you'll get crazy. It's really the cars are 4 times the number of trucks. So cars are 4 times the number of trucks. Okay, next one, number 24. A population, that's going to be a variable p, increased by 30%, that's our data, is equal to the final amount. There's another variable that we don't know. So a population increased by 30%. Now as a number, 30% is 0.3. But they never stand on their own. It's always 30% of what? And it's of that original population. So p plus 0.3p equals the final amount. And of course, if you wanted to write that shortcut 1.3p equals the final amount, that would be perfectly fine as well. In fact, let me write that out. 1.3p is the final. All right, number 25. The original price, there we go, that's our variable right there, decreased by 15%, 0.15 of the original price, P, is equal to the final cost. You'll notice these are the formulas from those word problems that we're going to do in a bit. The percent changes, and so that's 0.85p. You could write the first one, or you could just write the second one. Both of them are acceptable answers. Good, so these are the translation problems. Now we're going to do some word problems where they actually ask us to solve them. Much more exciting. Jeff pays $25.99. Remember, that's the data. We've got that one. Gives him 200 free minutes. Okay, that's something to note. He pays 7 cents for each additional minute. His bill is a total of $35.30. How many total minutes did he talk? So we got to pick our variable. So the total number of minutes, these 200 are free. Let's pick X as the additional minutes. So additional minutes are the X. So he pays $25.99. Now we're going through the plan, plus 7 cents for every minute. So for each additional minute. So times by the number of minutes, and that ends up being 35.30. Hey, look, we have an equation. We're back here, step 1 through 5. Do we have any parentheses? No. Fractions? No. Multiple x's? No. We're down here. We subtract 25.99 from both sides. And that is 0.07x equals 9.31, I think. Let's double check that on the calculator. 3530 minus 25.99. Enter. Yep, 9.31. Now in order to solve this, we're going to divide by 0.07, divide by 0.07, and so x will be 9.31 divided by 0.07. Enter. 133. Now that means he spoke 133 additional minutes. That's what our X was. Word of caution, how many total minutes? Total, the answer is 433 minutes. Yeah. Oh, that was a good one. Okay, 27. 57. Number, 15 less than twice a number. What is the number? There's our n for variable. So we have 15 less than, so we're going to be subtracting twice. That's a 2 times. 57 is a number we're going to use. Now we got our variable n. Now let's get our plan. Translate it. 57 is 15 less than. That means subtracting 15 from twice a number, 2n. Hey, look at that. We have an equation. We're in happy math land. All powerful. Get rid of our parentheses. We don't have any. Fractions? Nope. Multiple n's? Nope. Add or subtract? Yep. Let's get rid of that 15. Get rid of that 15 on both sides. 57 plus 15 is 72 equals 2 times n. Divide by 2, divide by 2, and n is 36. 36 was the original number. 57 is 15 less than twice 36, and you can check that answer out. Yeah, look at that. We made an equation. Happy math land. All right, number 28. Frank has taken 4 tests and scored 79, 85, 82, and 90. What does he need on his 5th test to average 86? So here's our original data points. Average, that's important. We're going to add and divide by 5, 86. What does he need on his 5th test? So there's my variable, f. So if we do the average of all 5 tests, it is 79 plus 85 plus 82 plus 90 plus his 5th test. All divided by 5 have to equal the 86. Look at that, we have an equation. Think through with our plan, have our variable, we got it. We're now in happy math land. Let's do it. Do we have any parentheses? No. Do we have any fractions? We do have a fraction. Let's get rid of that 5 by timesing both sides by 5. Now notice on the left-hand side, when we times by 5, it goes away. It's gone. And on the top, let's simplify those 4 numbers. 79 plus 85 plus 82 plus 90. And we get 336. So we get 336 equals, plus f. Better put that guy in there. Plus f equals 430. Okay. So we got rid of the fractions. Do we have multiple f's? Nope. Add or subtract? Yeah, let's get rid of that 336. And the f will be by itself. And f equals what? 94. Let's just double check that I didn't do that wrong in my head. 430 minus 336, and that is 94. So he has to get 94 to average 86 on his test. Probably that 79 is what killed him. All right, number 29. 3 consecutive even integers are such that, okay, let's start. We know what consecutive is. Even. If you start off with an x, the next even one is 2 higher than that, and the next even one is 4 higher than that. So if we started with like 36, then it'd be 38 and 40. Okay, are such that, here's where, okay, we've got our variables. This is our plan. The sum of the smaller two is, so these guys added together, x plus 2, is, that's the equal sign, 72 less than, that's minus 72 off of 3 times the largest. So there's the smallest two that sum together and 3 times the largest one. So of the 3, those 3 numbers. Okay. Whoa. No, we don't have to whoa anything. We're in happy math land. Look at this. We've got an equation. We know how to do this. Are there parentheses? Yes. Jump the 3 in. So we have x plus 2 equals 3x plus 12 minus 72. That's a 12 there. Combine multiple x's? Yes. We have 2x plus 2 equals 3x minus 60. All right. Oh, we got to combine them all on one side. We either got to get rid of those 2x's or that. So subtract 2x, subtract 2x. We have 2 equals x minus 60. Step number 4, get rid of any addition subtraction. Add 60 to both sides. We get x equals 62, and we have no multiplication and division. So we have our number 62. The next one up is 64, and the next one up is 66. Excellent. There you have 22 through 29.